trigonometry. Here you have the 7th question, exercise 11.4. Prove that sin A plus cosecant A whole square plus cos A plus secant A whole square equals to 7 plus tan A plus cot square A. 7 plus tan square A plus cot square A. Now here they are asked to prove that where sin A plus cosecant A whole square plus cos A plus secant A whole square equals to 7 plus tan square A plus cot square A. To prove this, so now let's consider this sin A as A. Okay, let's consider sin A as A and cosecant A as B. Where here we got where A plus B whole square, right? By using a formula where A plus B whole square, as we know, A plus B whole square equals to A square plus B square plus 2AB. So A square plus B square plus 2AB. Okay, by using this form, okay, here by using this, you have A plus B whole square equals A square plus B square plus 2AB. By using this, we can write like A square. Here you have sin. So you can write A square as sin square A plus B square as cos square A. Sorry, cosecant square A. B square as cosecant square A plus 2. A as sin A. 2 sin A. 2AB as sin A into cosecant A, right? Sin A into cosecant sin A into cosecant A plus, now here just look at the other side where you have cos A plus secant A whole square. Now consider this cos A as A, secant A as B. Okay, we again have we got A plus B whole square, right? We got A plus B whole square, where A square plus B square plus 2AB. As here we can write A square as cos square A and B square as secant square A plus 2 cos A into secant A. 2 A into B as cos A into secant A. Done. We have written like this. Now just rearrange this. Now we can rearrange like you have sin square A and cos square A. Now let's rearrange like, let's write down sin square A plus cos square A plus, here you have cosecant square A and secant square A. Now let's bring so cosecant square A and secant square A together, as we can write cosecant square A plus secant square A. Done. Now here plus, we got 2 sin A into cosecant A. Now let's write down here 2 sin A into cosecant A and 2 sin A into cosecant A plus 2 cos A into secant A. Okay. Now we have rearranged this. Now just make a look here. You have sin square A and cos square A. As we know, sin square A plus cos square A, we have a trigonometric identity where sin square A plus cos square A equals to 1. Okay. By using the trigonometric identity, what have we used here? We used sin square A plus cos square A equals to 1. Okay. By using this, sin square A plus cos square A equals to 1. Here I have written 1. Now let's arrange this as, okay, square A plus secant square A as it is. Secant square A plus 2 sin A. Let's write down here 2 sin A into, here you have cosecant A. As cosecant A can be written as 1 by sin A. Okay, as we know, cosecant A, we can write cosecant A can be written as 1 by sin A by a trigonometric identity, and here you have 2 cos A into secant A. As secant A can be written as 1 by cos A. Okay, here we know that where cosecant theta equals to 1 by sin theta, thus here I have written cosecant theta, cosecant A as 1 by sin A, and secant theta, we know that secant theta equals to 1 by cos theta, thus I have written 1 by cos A. Now just make a look, we got 1 plus cosecant square A plus secant square A plus 2 sin A into 1 by sin A plus 2 cos A into 1 by cos A. Here where sin A and cos A gets cancelled, and cos A and cos A into cos, so sin A and sin A gets cancelled, cos A gets cancelled. Now here if we again write further step like this, now let's write down this step as 1 plus, okay, you have cosecant square A plus secant square A. Let's write down here like cosecant square A plus secant square A plus, and here we got what, 2 and 2, okay, 2 got and 2 remained, as we can write 2 plus 2. Now just we can write the next step. Further step can be written as, you have 2 plus 2 gives what, 4 plus 1 5, right? As here we can write 5 plus cosecant square A plus secant square A. Cosecant square A plus secant square A. Done. Now we got 5 plus cosecant square A plus secant square A, but they asked to prove that 7 plus tan square A plus cot square A. Still we haven't got the correct one as now. Let's write the further step here as, now here you have, okay, we know that you have secant square A, right? Sorry, cosecant square A. You have cosecant square A. Now we know a trigonometric identity where cosecant square A minus tan square A. Cosecant square A, yeah, minus tan square A equals to 1. Done. Now here if I transpose this tan square A to the other side, minus becomes plus, as I can write tan square A plus 1 equals to cosecant square A. Right? Now here you have secant square A, where secant square A can be written as, now we also have a trigonometric identity based upon secant square A, where secant, let me write it down here, like, let's just consider this as first one, okay, where secant square A minus cot square A, okay, equals to 1. Instead of A we can place theta as secant square theta minus cot square theta equals to 1, or cosecant square theta plus tan square theta equals to 1. Okay. Now here you have a secant square theta minus cot square theta. Cot square theta equals to 1. Now here if I need secant square theta, so if I transpose this cot square to the other side, this becomes plus, as I can write cot square theta plus 1 to secant square theta. Then secant square theta. Now here just consider this, guys. You have okay. Now just consider this for cots. Okay, where cot square theta plus 1 equals secant square theta, tan square theta plus 1 equals to cosecant square theta. By considering this, as can we write like let's use the other one, where can we write like 5 plus cosecant square theta can be written as tan square theta plus 1 plus secant square theta we can write as cot square theta plus 1. Then now here we have 5 plus 1 gives 6. 6 plus 1 we got 7 as, let me write down here like, let me write down here like 7. Here we have 7 plus tan square theta plus cot square theta. Done. Now hence prove, therefore hence proved that where 7 plus tan square theta plus cot square theta, here we got 7 plus tan square theta plus cot square theta. And